Okay, hi everyone. In this tutorial, we're going to learn how to make this box that will be ready to laser cut. If I go into my solid view, we'll be making something like this. Now, as I've mentioned in these tutorials many times, there are specialized software that can do this at a more sophisticated level and a lot quicker. What I'm really trying to get across in these tutorials is how we can use Blender as like a very general problem-solving environment, even though it's designed for animation. We can do quite a lot of different things. To me, the benefit is, first of all, Blender is completely free and open source, and it's very adaptable. What I'm going to show you how to make here, I won't be using any add-ons. I'll just be doing some very simple modeling. But there are some great add-ons that can help you make much more sophisticated objects for laser cutting. But I'm just going to show you some simple workarounds to get what you need. And also, there is a little bit of convenience here because we can design our entire structure and animate it all in the same environment, and we'll know where the holes have to go and everything like that. Okay, so just to give you, a counterexample, making a box like this, you can just do on a website like makercase.com. You can put in your measurements and you can download this straight away. So I know there's plenty of other ways to do it. I'm just showing you how we can use Blender in this quite nice sort of integrated way. And it encourages us to keep improving our modeling skills. All right, so this box that I've made here, I'm going to hide that. I'm going to make a new one. And also, I'm going to move my the parent empty that we made for our mechanism. I'm going to move it back to 0, so we're modeling in the middle of the space. It just makes things easier. And I'm going to hide a bunch of our other collections, and I'll just leave the mechanism display revealed. I'll hide our flowers, our vase, and I'll probably even move this up so we are right there sitting on the x-axis. I think that'll keep things nice and straightforward. I'll just check from the top. We're in the middle. Great, keeps things easy. Okay, so I'm going to put my 3D cursor to the world origin, so it's in the middle. I'm going to Shift A, I'm going to add a cube. It's going to come in very big. I'll change its dimensions to 0.1 or 10 centimeters. And then I'm going to grab it, GZ, and I'm going to move it by 0.05 or 5 centimeters. Let's look from the front, and I think that's already basically how we had intended things to work. All right, now I'm going to delete the front face just so we can see what's happening on the inside. So I'll go into edit mode, face select, and just get my selection tool, click on this front face, X, delete faces. Okay, and we'll just have a quick preview of what our box is going to look like. I'll press Command A to apply the scale, and then, which can also be Object Apply Scale. And then I'm just going to add a solidify modifier to show you how the box will look once it's made out of our laser cut wood. And our laser cut wood is 0.003. It's 3 millimeters thick. Okay, so I just want to check that everything's kind of in the right spot. So if I go into my wireframe view now, the pin is sitting inside the box. I might even move my box down just a tiny bit, maybe something like that. Okay, and this peg here is going to spin through a hole there. That's good. And I might even G, X, and just have it so that we're in the middle of that gap, just so everything's perfectly in the right place. Okay, so I'll go back into our solid mode. Good. So now I'm going to actually delete that solidify modifier, and we're just going to quickly model these into the pieces with thickness so we can know where all of our laser cuts and our joins are going to be. So I'll show you a little trick. If I go into edit mode and I select a face, I can right click and say separate selection. And now that face is a separate object. But before I get too carried away, I'm going to put these in a new collection, otherwise I'll have a lot of things that are called cube. So I'm going to select both of these and M for move, new collection, and let's call it laser cut box underscore display, because this is just going to be the one that's in our animation. I'm going to duplicate it before we laser cut it, and I'm going to call it display 2 because I've already done this once just to get my method nice and efficient before I record for you. All right, and then I'll just go ahead and repeat that process and separate the rest of the faces. So edit mode, select a face, right click, separate selection, and I'll just do that for the rest, the rest of these faces until they're all separate objects. I think they are already 1, 2, 3, 4, 4, 5. Great. Okay, so we have 5 separate objects. That's nice. All of their scale is 1, so that's good. So I can now put that solidify modifier back on. I'll pop it onto one of them. Solidify 0.03. Oops, sorry, I missed a 0. There we go. And now I want to have the same modifier on all of them. So another trick we can do is if I hold down Shift and I select the other faces, and then I'm going to reselect the one that has the modifier so it becomes the active object, so it's kind of got this yellowy color. Then I will press Control L and I will say copy modifiers. Boom. Now they've all got the same modifier on them. So that's a great trick. If you're ever doing complicated things with modifiers, you can do the same by copying the materials from one object onto many. It just saves you doing it to every single one. Okay, now I'm going to do a little bit of adjusting. What I want to do is I want to back these, remove the 3mm thickness of each piece, just back so I've got what I'm going to call like an empty corner, and it makes the modeling easier. So I'll just do that quickly. I've got my snapping on. I'll go into edit mode, select this face. Can I get it? Oh, I need to apply my modifiers. Of course I can't select the face. Right. So I just need to either go apply like this, or I can Command A with my mouse hovering over the modifier. That will apply the modifiers. Right. Okay, so now we have these meshes. I can select that face and I'm going to just go GZ and snap down so that we are matching the thickness, GZ. And what I'm also going to do is do that to the back. So I'm going to use the other faces as a measuring tool. This will be GY. And then I'm also going to do it, basically I'm doing it on every edge, so we get these, what I call like an empty corner. Okay, so I'll do it here, and I'll need to do it on this side too. GX, ooh, yep, that snapped the wrong one, there we go. GX, GX, and at the back, GY, and on the side, GZ, on the bottom, GZ. Okay, empty corner, that's not an empty corner yet, so I need to bring this one in. GX, GX, oops, went too far, GX. For those of you who use Rhino, you might think this is a really slow way to make a laser cut box. You're kind of correct. Oh, sorry, I think I've already done that one. Oh no, I haven't. That's GZ. It's just, I don't know, it keeps us working inside Blender, and I think it's just for something simple, I think this works pretty well. This is the slowest part, just bringing all our corners back. It looks like I need to bring this one back here, GY, and this one back here, GY. Okay, so I just want to check I've got empty corners here, 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 here. Okay, this one I've forgotten. GX. Okay, that looks perfect. Okay, and now for the little trick. I'm going to grab every face and I'm just going to say Command R to do an edge loop. Make 2. Aha, my snapping is still turned on. I need to turn off my snapping, otherwise my edges go into weird places. Command R, double click. And Command R, double click. Command R, double click, Command R, double click. So I'm just using the scroll wheel of my mouse to make that second edge loop, to go from 1 to 2. Oops, yep. And then Command R, double click, Command R, whoops. Command R, double click. Okay, have I missed any? Yep, missed the bottom one. Command R, double click, Command R, double click. just check I've got them all. Okay, great, we're almost there. Now I'm going to go into edit mode and face select, and I'm just going to make some extrusions. So I'll start with the top, and I'm just going to turn my snapping back on, E for extrude, and it's going to snap in one direction exactly to these edges. And then we've got our finger joints. Whoops. Oh, did I accidentally extrude that already? Nope. Okay, E for extrude, left click, great. And I'll do the bottom one as well like that. So E, E, E. Okay, and now we'll just do the corresponding finger joints here. Okay, now we'll do that at the bottom. I could even do 2 at a time. Works perfectly fine. Okay, then what I'll need to do here is these are going to need to come out together like that. And we're going to have another little tab coming there. That's looking pretty good. So here I'll just do the same. Grab both of these, E, grab both of these, E, and then grab 1, 2, 3, 4, E. Okay, and then I'll do this back tab, so that's going to come, these two are both going to come up, E, E. Okay, I think that's it. Oh no, I've missed the sides. All right, E and E. Great. Okay, so there is the pieces for our laser cut box. The other thing we can do is we can add the holes. So if we want to have a hole exactly where that pin is, well, we can just use this to cut the hole. So if I go here and I click Boolean, I think we've used this modifier already. We're going to go difference, and I'm going to use this pin as the thing that cuts the hole. And similarly, now in this case, we can't actually use this to cut the hole. I'll show you why. Because remember we made this D pin. So remember we made this D pin here to control this hex pin here, and it couldn't be round because we need to make sure that rotating the crank makes this little shaft rotate. Now if we cut a hole that's shaped like that, then this won't spin through the wood. The hole has to be round. Okay, so that's what we've got to fix up. Should be pretty easy to work out. I'm going to just go Command S and say cursor to selected, and I'm going to add a cylinder, scale it by, I don't know, 0.01 or something. I'm going to rotate it on the X axis 90 degrees, rotate it on the Z 90 degrees, and then I'll look down the X axis and I'm going to scale it until it's just a tiny bit bigger than that shaft. And this is what we're going to use, GX, oops, turn off my snapping, GX, and I might say SX, and that's what we're going to use to cut the hole. Okay, so now where did that object go? It's here. Let's call it, I don't know, box cutter, just so we know what it is. And I'll put it in, we've got this little collection we made before called Boolean cutters. I'll pop it in there. And then on this, I'm going to put a Boolean here, Boolean, and for the object, I'm going to write box cutter. Okay, so that should work now. If I isolate select, we've got, okay, we don't have that hole going all the way through. Let's just check either our box cutter is not positioned correctly. Let's just have a look. Yes, I haven't put it in the wrong spot. I just need to move it GX so that it's going straight through. There we go. Now I'll hide the Boolean cutters, press the question mark to isolate select, and great, there's the hole. Very, very nice. Okay, I should check. I might have made the same mistake here. Yes, I have. That's also a D pin. So what I'm going to do is I'm going to find that box cutter shape and I'm going to duplicate it. Turn on my Boolean cutters, grab box cutter, Shift D, rotate it 90 degrees, and we're going to put it in position here because we don't want to have a hole that something can't turn through. It'd be totally useless. Okay, so I'm just going to use my top view to position it. It's really close. That looks good. Okay, good. Now, so I'll just, on this one, I'm just going to remove that pin and let's say box cutter, and it'll be this second one, box cutter.001. That should be the copy we made. And we can check that by isolate selecting, and yes, there's a hole. Wonderful. Okay, so there's our box. It's almost ready, almost. What I'm going to do is I'm going to right click and duplicate this collection, and I'm going to call this one laser cut box, I don't know, cut. So it's the one that we're going to use to cut, or maybe we call it like export or something, a bit more elegant. Okay, so I'm going to hide the display one, and we're going to have to make a few little changes. First of all, I can hide our mechanism display and I can hide our Boolean cutters. Okay, so there's two things we're going to need to do. We're going to need to apply these modifiers so that the holes will be permanently cut. Because at the moment, if I move this, you'll see the hole, it only stays where that cutting object is. So we'll need to apply that modifier. But there's one other thing we'll need to do. And this is where it gets a little bit into guesswork. But if we look closely at this object, our joins here or our tabs and our sort of miter gaps here are the exact same size. If I go into edit mode, they're lining up perfectly. Now that could either be a perfect fit join, but there's something that happens when we laser cut where the laser cutter itself burns away some of the wood, and that's called the kerf, K-E-R-F. And so what that usually means is we have to compensate for the width of the wood that's removed. So either our join is not too loose or too tight. It's exactly the same thing if you're doing woodworking manually and say you're using a hand saw or a circular saw. You know, a circular saw will remove, 2 or 3 millimeters of wood when you cut it. That's what all the dust is. So you have to know, where it's going to remove the wood from so that you still end up with a piece of wood that's the correct size. So unfortunately, every laser cutter has a slightly different kerf. It's a little bit hard to generalize. I did some testing, and in our little notes here, I came up with a scale for this of 1.5% is just the tiny little bit of compensation we're going to add. And it's really easy to do. Basically on the top part or anywhere there's a tab, we're going to make it 1.5% wider. And to me, it makes the fit just a little bit tighter, and it'll make putting your box together a little bit easier. So if I go into edit mode and I go into wireframe, go into edge selection, with that top piece selected, I'm just going to drag. So I've just got the middle section here, and I'm going to say scale Y 1.015. And when I hit enter, you'll see almost nothing. There's just a tiny little gap we've created here. Maybe I'll do that again so you can see. I'm just going to adjust my clipping so I can get a little bit closer. So if I hit undo there, oh, that's interesting. What just happened? Okay, there we go. All right, I must have hit something else. Okay, so if I do that again and I'm a little bit closer, S, and we're on the y-axis, SY 1.015. See, it's made that tiny, tiny little move. SY 1.015. That should be, hopefully, not too far. Although, to be honest, it looks further than I'd like. Yeah, that looks too much. I'm going to go SY 1.01. I think that's better. Let's try 1.01. I tested this yesterday. So what I recommend is somebody can check this. Try 1.01. That 1.015 worked for me, but it is a little bit tricky to get this right. So we might have to find the exact right number, but I think 1.01, I'm going to be a bit conservative here. So let's go SX 1.01. So I've done these two tabs, and then we'll do it here. Edit, wireframe, grab here, and this will be SZ 1.01, and grab the tabs on the bottom here. Wireframe mode, just drag select to get the tab, SX 1.01, and this way as well, SY 1.01. Okay, so what we've done is we've made a compensation for the kerf, so hopefully it should be a nice tight fit. I do recommend testing this just to double check, so maybe the first person who does their cut, check that it's not too tight or too loose, and you can always adjust that number a tiny bit. Okay, so now what we're going to do, I'll just go back into my layout, got a bit more space to look at, is we're just going to get this ready to laser cut. So we've got to apply our modifiers here, apply and apply, good. And then we're going to, I'm just going to put the origin of all of these at their geometry. Because we made them from a square, if I rotate this, Rx, you'll see it's rotating around the center because it still thinks that center is where the original cube was. So we just need to reset that by saying set origin to geometry, and it'll make it easier for us to position these in space. Set origin to geometry. Now I'm just going to put all of them at 0, 0, 0. And the ones that are rotated, I'll rotate on the Y 90 degrees. And this one on the x-axis 90 degrees. Okay, that's good. And then I'll look from my top view and I'll just space them out like so, GX, GX, GY, and I'll just press G. Okay. And we can be efficient with our use of space. The bigger the gaps here, that's just wood you're going to waste, so have them, you know, nice and close together. It'll be more efficient. I wouldn't put them, you know, any closer because then you might end up, you know, having your models cut each other and things might go wrong. So just a little gap like that's perfectly fine. Okay, so now here's a cool part. This is where we can render a vector image, which is what we need to laser cut. We can render vector image from Blender. So we just need to make a camera that's looking directly at this. So I'm just going to put my cursor back to the world origin. Shift A, I'm going to add a new camera, and I'm going to set all of its positions to 0. Drag it up, GZ, and we're going to set it to be an orthographic camera. So what's an orthographic camera? An orthographic camera has no perspective. Basically, instead of, I'll just do a really quick demonstration. I'll just quickly add a cube. Where are we? Add a cube. Scale it down. Go into our animation tab. So this. Okay, we're looking through a different camera here. So I'd want to click on this camera and hit View, Cameras, Set Active Object Camera. So now we're looking through our orthographic camera. And what you should be able to see, I'm just make it so that our camera moves with the view. There's no perspective. So if I make this cube really long, SY, okay, it's going to clip, it's clipping our camera a bit. I'll just move the camera away so we're not clipping. What you'll see is even, it starts to look weird. If this was a perspective camera, this would be getting smaller as we move far away from it, but it's an orthographic camera, so the distances stay parallel. And it's really, an orthographic camera can be really fun for making animations in an orthographic view. Orthographic views you'll find in a lot of computer games, like strategy games, they all use orthographic views. That's something, you know, we can talk about more at another time. But for us, we want to use this orthographic camera because we want to render something completely flat with no distortion from perspective. And I'll show you what I mean. I'm going to put this orthographic camera back to facing down. I'll delete this little cube I put in, and we're going to need to bring our orthographic camera closer to our objects. But because there's no scale, if I move this camera, you know, the objects, they're not changing size, they're either in or out of view. Orthographic cameras, we need to change their scale. And that's how we sort of zoom an orthographic camera. So I can make the scale like, I don't know, 0.5. And then if I'm looking from the top, I can just move my orthographic camera until my objects are perfectly framed. That looks pretty good. Okay, so the reason we don't want perspective is technically this point and this point are further away from the camera than this point, right? Like if you look at the camera this way, if we drew hold on. If we drew a line from here, oops. Why is that affecting my camera? There. If we drew a line from here to here, or a line from here to here, we have different distances, right? And so this and straight down will be the closest distance to the camera. Sorry, I've drawn my lines wrong. It should be like this. From here to here, or from here to here, right? So the things in the middle will be slightly closer to the camera than the things on the edge. So we'd have distortion, and these wouldn't be squares and rectangles anymore. And that is not what we want for our laser cutting. So that's why we need an orthographic camera for this type of work. If we want to render this into vectors, all we need to do is turn on a really handy plugin. If we go into preferences and look in your add-ons and type in free, and you'll see this thing, Freestyle SVG Exporter. Just make sure it's ticked. You might need to look for it here first. In extensions, you might need to hit install, and then add-ons, it should pop up. Okay, so once that's ticked, you just need to go into your render settings and make sure that Freestyle SVG Exporter is ticked, and this other little Freestyle button here is ticked. Then what you need to do is in your output, you need to tell the output where your SVG, which is going to be your vector file, where it's going to go. So I recommend, in your class folder, you're going to have a new folder called SVG, and you're going to be making vector files here. If you look at these numbers, these are actually the frame numbers. So it'll make a new SVG file depending on just where you are on your timeline. So if you don't move this and you keep making SVG files, it's just going to keep replacing that same one. So what you can always do if you're not sure, you can just, with the arrow key, or you can press spacebar and stop, you can just make sure you're on a different frame number, and that will make sure you don't replace the same SVG in case you want to make more than one. Okay, and then the last thing we need to do is we need to go down to our, I always forget where this is. Okay, it's down here. So it's in the View Layer tab, and we just need to look at the settings for our Freestyle. So you should have this thing here, Freestyle SVG Export, and another thing called Freestyle. Make sure they're all ticked, Export Strokes, Freestyle. And we're going to change our settings, so all we need actually is border. That's the only thing we need ticked, because we're just going to have the border of all of this. Oh, actually, we can have silhouette ticked. We can set this manually by doing edge marks, but I think I just want to make sure we get the outline here and those circles. So I'll just try a basic setting here with silhouette and border. Then I want you to go into Freestyle Geometry and make sure this number here is 10,000. What that means is if the number's too low, you start to get lots and lots of extra dots on your vectors, and there's just no need for it. It's a little bit inefficient. But when that number is set to 10,000, you'll just get a vector at every vertex of your geometry, which is what we want. Okay, so let's see how this works now. If I press render image, it's worked. And the reason I know it's worked is that I can see not only my render, but I can see these edges and I can see the circles. And that's exactly what I want. That's what we're going to use to laser cut. Okay, the next thing I'd like you to do, if you don't have it installed already on your computer, is download Inkscape. Inkscape is just, it's basically like an open source version of Photoshop. Oh, sorry, not Photoshop, Adobe Illustrator. I'll just check if, I think that's the official link. I'll put a link in the description. I might just double check that this is currently, oh no, here we go, inkscape.org, that's what I was looking for. Inkscape.org, maybe they have moved to the page I was just on. Okay, no, here we go, inkscape.org, all the releases, you can have it for Windows, Mac. It's great, it's free, it's open source, you can do lots of things with it, and it won't cost you a cent. So, yeah. All right, so download Inkscape, and then once you've rendered your vector, we're going to open Inkscape, and you can see I've already done this once before. I'll delete this, and so you can just make a new file, and it should look something like this. You can set the size. If you go document properties, I've got mine at A3, which I think is about right for what we're working on. So I'm just going to File, Import, find my SVG, hit Open, and I'll get a little pop-up. I'll just click OK, and there's my SVG. Almost ready to go. We need to do a couple of things. I'm going to rotate it, so you should have these things here to rotate. Otherwise, I think you can look in perhaps Object Rotate. That will also do it for you. Object Rotate. Okay, now there's one strange thing that I notice often happens between the Blender export and an SVG. There's sometimes a slight issue with scaling, and I want you to check this. So these should all be 10 centimeters by 10 centimeters. That's like exactly what we made our box, but they usually come in something like 21% too big for reasons I don't really understand. So I'm going to highlight this, just make sure I'm just getting one box. And well, today it's 2%. Yesterday when I did it, it was 20% too big. All right, so I just want to check that I've just got one box. Yep, and at the moment it's 102 instead of 100. And let's just double check in Blender. If I click on that exact same piece, which I guess is this one, and I look at its size, it should be exactly 0.1 meters or 10 centimeters. So there's some scaling thing that I don't quite understand. I tried to look it up. It said it's something between how the Freestyle plugin works. If somebody knows the answer to this, please tell me. I'd love to know why I keep getting a slightly different scale when I import. But with this little thing locked here, I'm just going to type 100, and that on both axes will correct this to being the exact right size. So yeah, look, there are some things in doing this in Blender that are really convenient, and some things that we just need to check manually. Just check that's 100 by 100, that's great. Another thing you could do is if you just look up the ratio of what it was, 102 point something, 100 divided by 102 would give you the percentage, and technically you could apply that scale to all of these. I'm just being a little bit careful here, and because it's only 5 pieces, I'm just going to make sure I've got them all scaled perfectly to 10 centimeters, or in this case, because we're working in millimeters, 100 millimeters. Okay, always good to just do some checking before you cut. There's a phrase we say, measure twice, cut once, and that's kind of what we're trying to do here. Okay, so I'll just put that back in position. All right, that looks great. That looks ready to laser cut. We've got the 2 holes and all of our tabs. And now I'm just going to select these, and we're going to go File, Save As, and we need to save it. I've made another folder here in my 3D Fundamentals called DXF, which is the file format that our laser cutter uses. And under all of the options you can save as, lots of different things. We're going to click Desktop Cutting Plotter AutoCAD DXF R14. All right, and then I've done this a few times in my testing yesterday. I'm going to call this box 6, and I'll hit save. So now you can open that DXF on the laser cutting printer, and our technician or your course instructor can help you execute the laser cut. Okay, and that's it for this tutorial. Thank you. Bye-bye.